Hi guys, here's another question, a practice question for calculating the equilibrium constant using the table. Let's cut the chase. It says the following reaction takes place at what? 250 cubic centimeter. So that volume we're going to need it. So we have to convert that volume. We'll say 250 divide by 1000. We convert it into dm3, so it's going to be 0.25 dm3 cubic decimeter. Right, that's the container. So we have this reaction here, the chemical equilibrium reaction. It's a nitrogen oxide react with the bromine gas and NOBr gas. That's the product. Initially, the reaction contains 0.25 nitrogen oxide and 0.1 of Br. Right? When the equilibrium is reached, it is found that 0.2 of nitrogen oxide remained in the container. Calculated the concentration at equilibrium. Right, guys. Even though they did not ask the calculation of equilibrium there, they only wanted the concentrations there. I'm gonna continue till equilibrium constant, equilibrium value. So what are we going to do now? Since we're given the initials there, so we're given the initial, so this is the initial amount of nitrogen oxide and the initial amount. Let's substitute it there. So it's going to be 0.25, and the initial amount of bromine, it's 0.1. Right, it's in moles. This table worked with moles, and then there was no product initially there, and then we're told when equilibrium is reached, it is found 0.2 of nitrogen oxide remained in the container, which means it's an amount at equilibrium. After from this initial amount, a certain amount here has been taken, and then what will remain is 0.2. So 0.2 remained there, right? Which is its amount of nitrogen oxide that remained there. Very important. So next thing that we're going to do there, so we are going to as I did in the previous practice question, since there's a 2 there, so we'll say negative 2x. We'll say negative because it's the reactant. And then since there's a 1 there, so we'll say negative x. And then we equate that. And then since there's a 2 there in front, we'll say the plus, because it's a product, equal to. Now, what is going to help us to find those values there, these values there? It's these two. So always in the reactants we say what was there initially minus what is used and equal to what remained. So we'll say there 0.2 minus 2x equal to that, it's what was available and minus what is used, and this is remained at equilibrium, right? So it's 0.25 minus 2x equal to 0.2, and then if you do the math there, 2x is equal to 0.25 minus 0.2, which is going to be 2x is equal to 0.05, and then your 2x is 0.05, right? And then if we want x, we divide by 2 there. We divide by 2, your x is going to be 0.025. So my x, it's 0.025. And my x, 2x, it's again 0.05, right? So we can even check for the benefit of the doubt to say 0.25 minus 0.05, it's going to be 0.2. That's correct. And then here, since we only do that in the reactants, not in the product, in the reactants you subtract, you say this minus this is equal to that. So we'll say here this minus this and put the answer there. So the answer there it will be 0.1 minus 0.02, so it's going to be 0.075, right? And then in the products we add, we say 0 plus this is equal to that, so 0 plus 0.05 is going to be 0.05, right? So the next thing that we're going to do now, we have our number of moles at equilibrium, right? So we're going to convert to this number of moles at equilibrium to concentration at equilibrium using this volume, right? So what we're going to do here, we're going to say 0.2 divided by 0.25. So if you punch that in the calculator, it will be I'm opening the calculator. It's 0.2 divided by 0.25. It's 0.8. And then here we'll say 0.075 divided by 0.25. 0.075 divided by 0.25. It will be 0.3. And then it's 0.05 divided by 0.25. 0.05 divided by 0.025, it's 0.2. Now we calculated the concentrations at equilibrium. So calculating the Kc using these concentration. So we can say Kc is equal to concentration of product. The product, it's concentration of product, it's NOBR to the power 2 divided by the concentration of nitrogen oxide to the power 2 times by the concentration of bromine to the power 1. So that will be 0.2 squared divided by 0.8 squared times by 0.3. So punching that in the calculator, it will be 0.2 squared divide, oh come on, and then divide by 0.8 square times by 0.3. So the answer here, it will be, that's the equilibrium constant, it's 0.21. That's the yield. I hope that makes sense. Cheers, bye.